Hi, I'm Jimmy LaForge, Operation Manager of Jace Exterior. Today I'm here with Bob Drunkenmold from Dilworth Homes. How are you doing, Bob?
I'm good, thank you.
Good. And we are here to talk about what today?
Today we're going to talk about the exterior membrane and this SIGA MyVest product. So this MyVest 200, made by SIGA, is a mechanically fastened vapor permeable membrane. And it's also designed for moisture control and air barrier. So what makes it an air barrier is how it's sealed. So if you'll notice at the bottom here, that's your first start of the membrane. It's an 18-inch roll that we use underneath the wall bottom plate that comes up, that this membrane is later on taped to, goes all the way up and is taped to the top, as you can see, especially with corners and staples, as well as your rough opening is also taped, as well as your corners are taped, making this one solid membrane, which gives it a high permeable level factor.
Now, the good thing about the 3-layer material is that by stapling it and being in Canada, having all these weathers, this product won't go anywhere. You cannot rip it off. You got a staple right here, try pulling this off, it's not coming apart. And then after that, what we have to do is we have to seal off, obviously, all the seams everywhere. And the Wiglove 60 is a vapor permeable polyolefin. It's also a reinforced mesh, and it's got a pressure-sensitive glue, which the glue doesn't actually activate until you use a roller on it. And if you come here and do a little close-up, you can tell when you actually use the roller, all the honeycombs stick out, and you can see that the glue is actually activated. If you do not do this step, you will not get the right results. So make sure you purchase one of these and you do it properly.
It starts with this bottom plate material. Bottom plate material is like so. Plate a acoustical seal and acoustical gasket on top, and this comes up. And this bottom plate, which is this, is then taped in to the membrane that the siders put on and works its way all the way to the top, which is now tied into the top plate material and then taped, as Jimmy has pointed out, which creates your mechanically fastened vapor permeable membrane and one solid air barrier as it is taped on top and bottom.
The most important thing for Jace Exterior is to come in here once the sheeting is done and make sure that we wrap all the openings properly. It's very, very important to make sure that the sill plates are done properly, the gussets are done properly. They have the Wiglove 60, they have the Wiglove 100, the 150, and then the 230. So we use the 230 for the sill plates because it's a 9-inch. And just before you install it, when my installer put on the paper, we cut down about 1 inch to make sure that the sill wrap will come down and actually glue on to the OSB and then onto the paper. That's the proper way of actually doing it. So the one thing that we want to make sure is that the rough opening is sealed properly before the windows get installed. Once the rough openings are done properly, Dilworth gets their framers back, install the windows. Once the windows are in and we come back to install the siding on the house, we go around with the Wiglove 60 and we seal off any opening that was added on after. So when Jace Exterior comes in, it's very important to make sure that we seal it properly. And as you can tell, this is sealed properly now. It's ready for install. This is, and this is not. And once the window opening goes in, again, we seal it to the membrane, making sure that it's sealed off 100%.
Hey guys, I'm Lance. I'm Chase. We are the owners of Lake Valley Homes. And we're here today. We're going to talk about how to build a nice airtight house using the zip system. Let's go have a look at Cliff Edge Manor. Let's check it out. So we're down here now at Cliff Edge Manor, and we wanted to show you kind of a ground up of what we've done to make this a forward-thinking home. So we got our ICF foundation, and we've wrapped it with a new product called Hulk Systems. I'll let Chase explain to you exactly what that is.
It's a elastomeric product, and it's actually embedded fiberglass and then recoated twice. So it can actually withstand, you know, nice shot of the old sledgehammer. So how many damp proofings can do that right now?
So now that my brother Chase is done beating the house with a sledgehammer, let's have a look at how we sealed the wall to the foundation here using liquid zip system flash.
So we've been doing the sausage tubes, and then this is one of the trickier spots to get in. So what we do is actually we wrap the ICF, we wrap that damp proofing underneath our bottom plate, put our sill gasket, and then we finish it with the caulking.
So I don't know about you guys, but I was so sick of driving by a site, seeing Tyvek upside down, blowing in the wind, half on, half off, ruining your wood. Look how clean this looks. Air barrier, weather barrier, everything on the outside, locked, sealed, taped.
And we've talked with our framers. We made sure everything lines up from bottom framing all the way to the top floor. That way all of our sheets can stand. And then we've actually ordered 10-foot sheets to overlap that rim joist to make everything continuous and sealed.
And when it comes to cost, I know everybody looks at that first number of sheet for sheet, so much more expensive, but you got to dig a little deeper than that. You got to take away the scaffolding you got to do to send a crew to come do Tyvek after you. You have to take away the cost of the Tyvek. And honestly, the cost isn't that much difference, and you got way cleaner of a build. So we wanted to show you what the wall looks like on the inside, and the bonus of being able to stand your sheets. Seamless. There's no cracks, there's no air protruding.
Yeah, we've got the one horizontal seam where we've overlapped the rim joist going down to the basement, but with the zip system, it actually has a rabbeted edge that allows for expansion. So you can get those sheets right tight on top of each other. You tape that seam, you've got an airtight wall. You can see how clean these cavities are. This is someone's dream home for a long time, and you want to make sure the bones of that house are structurally sound. That's a great way of keeping everything behind the walls nice and dry.
Okay guys, Chase is going to show us how to put the stretch tape on our windowsills and how we seal everything in.
Yes, so if you come on in, we'll show you exactly how we do our window dams. So we start with a piece of our regular zip flashing tape. You can get this in various sizes. So whether you're doing outboard insulation or just the standard 7/16 sheeting, you can get different sizes. So here we just use the 3.5-inch tape to get that first piece on. And then we do 12 inches up and 12 inches over with this incredible product, the zip stretch tape. This stuff here, you can just get right into this corner, give that corner a nice tug like this, and it just stretches to wherever you need it to go to. Make sure everything's nice and tight. Then we finish everything with just a simple J roller. And there you got probably the easiest window dam to install. So a couple different ways you can do your depths. What we've noticed is we find we'll get the depth of our window jamb, and then depending on that window jamb depth, that's where we like to set this tape. And then that way when we do our caulking that we're going to speak about here shortly, it finishes that seal right to the edge of this tape so that the tape's not protruding past it, and then you have those cracks in the corner. So that's what we've noticed is the best way to do it. So the key to this system, and I know it might be tricky for some people, but having your framers on board with this system is key. Like really, if you zoom in on these nails being set the exact depth, that's kind of one of the main parts, because you don't want to drive them in too deep. Otherwise, you got to go back and caulk them all, right? So we use galvanized nails, make sure everything's set perfectly, and you don't have to go back again.
And again, taping as you go, right? So as we're standing walls, we're taping, everything's getting done and locked in as we go. And this can sit out here for 6 months, fully warranted, no issues.
Yeah, and then now the whole wall's done, finished, and we can now attach our balcony to it and not have to worry about touching the actual structure of the house. So this is a Wintegra tilt and turn window. It's actually a Rehau frame, kind of a German hardware on it. And what we do, it's got the nailing flange on it. So we nail the flange on, we leave the bottom open, so if there's any kind of condensation, it can still run out. And then you tape the two legs and the header, and then you've got that exterior seal on your windows.
So we wanted to show you how we finish the window on the inside. We have our backer rod and then our caulking with it. Seals everything nice, perfect to our stud.
And we've been doing this instead of spray foam recently, and we find the air tightness is a much better seal, just because it gives that window, if there's any chance of movement or anything, that spray foam cracks, there you go, you got air in your house. So this is the best way to do it we've found.
And honestly, guys, it's really easy to do. You just got to change your way of thinking a little bit. And we've been hitting step 4 on all our builds, and the air tests they've been easy. But you just got to stick to these little details, make sure everybody's on board, and we can make it happen.
Here we've got our ICF wall. This is quad lock. That's what our framers and our foundation workers are comfortable using, kind of the system we've been going to. One thing we do here different than, we don't rely on the ICF for our basement wall. We still do this service wall. Lance will tell you some good reasons why.
So number one, all of our trades that go after us, they love this part. They can run all their stuff in the walls. They don't have to fight with insulation. They don't have to take a chainsaw and run through their tracks. Also, we can make our walls perfectly plumb. The other way of just gluing your drywall onto the ICF, you end up with a wall that's not plumb. We do a ton of millwork in our homes. So this is just a way, it's not that much more and it saves you money in the long run. Chase, what did we do underneath our concrete?
Underneath the concrete, we've got another 4 inches of underslab insulation, and then all our frost walls are also ICF. So we got that continuous insulation there. We've got no thermal break whatsoever on the exterior foundation walls, and I mean, you can keep this basement cool or hot, whatever suits your needs.
So a lot of people are worried about step code 4 and what's my house going to look like? What do I have to give up to create that step code 4 achievement? Honestly, guys, look around. Look at the amount of glass we're able to put in a house like this. And the nicest part about it is, you know, with the step code 4 windows that we've used with our energy advising modeling, we're able to stand here whether it's summer, winter, fall, spring, and it doesn't change. The comfortableness of the house, it stays the same. Doesn't matter what season it is, it's always going to be the same for you.
I think that's the biggest selling factor on any of this. It's not necessarily, you know, you have to do this, you got to cheat this way to make step code. It's making your house comfortable to live in. You know, everyone's lived in one of those 80s houses where you get that draft beside the window and you can't find a comfortable spot on the couch. Be like, a house like this with its airtight seal and all of the energy products we've used, the house is going to be comfortable and you and your family are going to be super happy.
So Chase, why don't you show us what we did with the top plate here and our poly?
If we could have spray foamed the attic, would have been nice, but because we're going to do an R60 insulation blowing in, we have to have that poly because it's going to be vented. So what we've done is we tuck our poly in before putting on that top plate, and we actually acoustiseal it to the back side of the zip board. And then whenever our sheeting comes in, once our trusses are done and we're ready for insulation, this poly is going to get taped up to the underside of the ceiling poly, and that's going to give us our nice continuous air barrier. And then the only thing we have to worry about is making sure all our light cans and everything are well sealed.
So we wanted to just wrap this up and go over, you know, the difficulties we've had and the good things we've had in working with our trades and our team members on how to achieve these things.
Yeah, we've seen kind of pros and cons of the system. I mean, this isn't our first project using Zip, so this has been the best going one so far because we kind of hashed out a lot of those little details, kind of, you know, making sure people aren't overdriving nails, making sure that tape is rolled, those kind of things.
I mean, honestly, your stakeholder meetings before all your next big steps on your projects are a huge part of it too. You know, our trades know if they rip some tape or they hit a nail too deep, they're gonna come tell us, or they're gonna fix the problem right away. You know, we don't care to pay them a little bit more money if it's to stop an issue right away versus them walking away and us not catching it after. So, you know, maybe it's something you talk about your trades, you know, if they got to do a little bit extra for you, you compensate them that way and everybody's on board. And in the long run, we all kind of win at the end anyways. It saves us a huge cost fixing it now versus fixing it later.
It's a very simple system if people are willing to work together. And that's it's probably the hardest thing to get people to do in construction. But I mean, once you have your right people and you get them on the same page, it is a simple task is to achieve these step 4 houses. It's it should be our standards, right? So there's a lot of benefits. You know, again, it's just laying out your pros and cons and, you know, making sure everyone's on the same page. That's the hardest thing.
Hi, my name's Marcus. I'm with Brentwell Construction. I'm the operations manager and we're here at our Manning Place development. What I want to highlight today is some of the details we're doing on our exterior air barrier for the sheathing and some of our vapor barrier details. So what we do here at Brentwell is just continue on the work from some of our great trades we deal with. So we're not trying to reinvent the wheel, we're just trying to improve upon quality and pay attention to detail, and we'll show you what we're about. One of the details we do here is on our plate poly details on the exterior walls. Instead of running them up and down, we get the framers to actually acoustical seal the plates at the top and the bottom to help seal it after the fact. That just saves us a lot of effort with the insulators. The other item we do is on our top plates, we've omitted the plate poly altogether, and we actually use an air sealing tape and tape all the plate joints together. What that does is creates a monolithic top plate, and from there the insulators can actually seal their lid to the plate poly, and it makes a more cohesive package, makes it easier to air seal, and we get a better final product. In addition to the interior poly that we do for our vapor and air sealing, we actually take a belt and suspenders approach, and we tape all of our sheathing joints and any penetration on the outside. This just ensures that any air that gets past one layer will be stopped at the other layer. This is a nice backup, and taping the exterior sheathing allows vapor through but not air, and so we don't have to deal with the vapor sandwich. And as far as that goes, it's been working pretty well for us so far. At Brentwell, we're pretty brand agnostic with whatever tapes we use. That being said, I like to use modern acrylic tapes. We find that they stick and adhere pretty well in most temperatures and seasons, and haven't had any issues. Since we're sealing the exterior sheathing as our secondary air barrier, anytime you have a penetration through that, we need to actually treat that penetration in a different way depending on what that item is. For most penetrations, we'll use an EPDM rubber sheet on that. We'll actually cut a hole smaller than the actual item itself. That way it'll be stretched, airtight, and no other products are needed for that hole. We then seal that penetrate or that EPDM sheet up, and from there we can actually shingle that and integrate that into our house wrap for the siding company to come along. This makes for a better home and less warranties, less callbacks, and less issues down the road. So with our combination of modifying some details on the inside and doing some air sealing on the outside, we're consistently getting into step 4 of the building code. And the idea here is we're not trying to reinvent the wheel, we're just trying to improve our processes slowly. So as the code moves along, we're gonna not get left behind. And as we move to different wall assemblies in the future, our staff are trained up, we have the skills, we have the products, and it'll be easy for us to achieve some great goals.
We worked with Marcus and the Brentwell team on this project here at Manning Place Inverted. Today we're going to be talking a little bit about proper window installation techniques, and as well as water management as it relates to your actual window product, and then its installation into the door envelope. First thing to do when you start your window installation is to ensure that the rough opening is square, level, and plumb, and that the sill is not crowned or sagging. Secondly, always ensure that you follow your manufacturer's instructions as it relates to shimming your window product. For the windows we're going to look at today, Geldwin recommends shimming a 1/4 inch from each corner of the window on the sill, as well as under any meeting rail or mullion. Thirdly, always temporarily install your window to check for to make sure it's square, level, and plumb, and that most importantly it operates the way it should. Windows are designed to manage water, whether it be weather stripping that's designed to shed water from the window, or filling gaps between the frame and the sealed unit. We'll also see drainage channels, normally in the track or in the glazing track on the window, and it's designed to move water from accumulating inside of the frame and guiding it to the exterior of the window and a weeping hole, so that it removes itself from the window itself.